Here we have a midterm question. If your major is chemical engineering or bioengineering, you are going to be really familiar with this type of questions because the lecturers are really like to ask this type of questions. I mean, it is for us. For me, it is like this. They really like to ask this type of questions. I mean, they use the planes, the centigrade degrees, or tank questions. They are really hard for me actually. So in this question, we have a function which is f, and it is asking that you have to find the highest temperature at the plane and the direction. Here you can see that we have 3 sub questions, and let's begin with the first one. The first question is asking the highest temperature at the plane. To find the highest temperature, we have to use the derivatives. So at the point of 0, we get highest temperature. So let's begin with the first one. You can use the derivative of x. The first derivative of this is going to be this. So if you do this, you're going to get the highest temperature in terms of x. And for y, the first derivative of y is and again I'm going to do this. In the point of 0, you're going to get the highest temperature. So for the b, the highest temperature is, we set that 0 to 0. If you write 0 both in the x and y, you're going to get, I'm going to write it anyway. 100 centigrade degree is the highest temperature. Let's continue with the question C. At this point, the greatest increase in temperature is asked. Here we have x, here we have y. We have to use a formula, of course, to find the greatest increase. Plus the partial derivative of y depending on t is this. So we just want this and this in the question of A. So I'm just going to write it. Sin alpha. So here we get minus. So we have to find the derivative again, of course, because we have to find the greatest increase in temperature, and when we find the derivative, we have to equal it to 0. So here the first derivative of this is cos alpha. If you do this, you're going to get the highest increase in the greatest increase in the temperature. So here we have 0. If you divide them to each other, you're gonna get this. And to find the alpha, then you get this. And I wanted to add this in the sub-question C. We have a direction. We are going to try to find direction to find the greatest increase in temperature. But in your question, it might be different, because in my question, we are trying to find the direction, not the divergence of a function. If you want to solve this in terms of the direction of a function of f, you can use another formula. I wanted to show this. And we found this and this in the question of A. So we have a divergence formula. We are trying to find this in terms of the divergence formula. So we have fx and fy. We just found this and this in the question of A. So here we get and at this point then the final form of the divergence of f at the point 3 and 2 . So we just write the question C in terms of the divergence of a function, which is f.